Let's get into the today's agenda. This entire session will be focused on application performance monitoring, which includes the various types of application we support. And the target audience for this webinar will be the system administrators, network admins, server admins, and most importantly, the DevOps team and the application developers and application support team is the target audience for this specific webinar. So we'll be starting off with gaining the code level visibility into Node.js and PHP applications, and how you can find the error traces of your applications, and how you can remove those errors from your application to deliver a rich user experience for your customers. And then we'll be discussing on identifying the specific business transactions which is causing slowness to your application, and finding the slow database calls that is again affecting your application performance. And finally, we will be discussing on inspecting the additional insights for Java-based web applications. So with this, let's quickly get started. So before we get started, I would like to show you a specific application, how an application is built in a real-time scenario. Okay, so we say that gaining code level visibility into Node.js and PHP applications. So before we discuss this, let's take a basic case of how an application is built. If you talk with any network admins or application developers, they have a dependency with multiple teams, right? And the reason behind that is your application is depending on the database. Application is depending on the web server. Application is again depending on the host servers. If any of these component goes down, that's where the application have a slowness, or the application may not work as expected if any of these component goes down, and how to find and fix those issues. And that's what we'll be completely focusing on today. So let me show you a real use case right here. I hope everyone can see this DevOps scenario, which I'm showing it to you. Say you get a complaint, the DevOps analyst get a complaint from the customers saying that their application is slow, and when they hit the URL of your application, it is taking long time to load, where the business is again impacted, and the user experience is impacted. So users again, they raise a complaint, and this complaint is again routed to the help desk team. Help desk team again routes the request back to the concerned team. Okay, this is how they resolve the case with the help of developers and with the help of the support teams as well. So with this, let me show you a sample image which depicts how an application is built in a more production-centric environment. I hope everyone can see this image. Okay, a user is saying that he can't view the image completely. Let me just zoom it for you. I hope you can see now. Perfect. Okay, so now I hope everyone can view this image. So what I'm trying to explain from those images, and web application in a production-centric environment consists of multiple components, which includes a NetScaler load balancer. It is always not a NetScaler. It could be a F5 big IP load balancers as well, because the load balancer typically routes the request to the web server, which is less loaded. If there is no load balancer, if there is a spike from the end user, your web server may not be able to efficiently respond back to those HTTP requests or HTTPS encrypted communications. So deploying a load balancer with the combination of web servers is again quite important. As you can see that this this load balancer has a multiple worker process which needs a continuous monitoring. If any of these process goes down, that's where again the load balancer may have an issue. So load balancer, WebSphere, I mean your web server. Along on the right hand side, again you could see that there is a MongoDB, and which includes Redis clusters also. Again, it is combined. It's a multiple technology distributed application. Okay, and you have an IBM API Connect, which is a third-party REST APIs, which is called inside your application for accessing a third-party content. And there is another log aggregators, and on the other hand, you have the internet users and internet users. So efficient monitoring of full stack is quite important in terms of gaining a complete visibility. So how to get that level of details from monitoring? That's that's what we'll be focusing. And I hope the agenda for today's discussion is clear with this depiction. I'll switch back to the presentation so that let's see the common reasons why your applications might be slow. So these are all the common reasons why your application might be slow. Say, as I was explaining from the image, that the web server might be overloaded. So we need to see how much request the web server is receiving. And if your web server is exceeding a so and so count, you can get an alarm from the from the monitoring tool, from the ManageEngine Applications Manager. And apart from this, there are few other health metrics, which includes the idle servers, busy servers information, and your if it is IaaS server, then worker IaaS worker process, that is the W3 WP process monitoring, is again quite important, specifically for web servers and your application pools, and along with the overall response time, right? So these metrics requires a continuous monitoring to protect your applications to be in a proactive side. And the other component, mostly all of the users know about this, that is the memory usage consumed by your application. Your application might have an issue if your application is running out of the memory, okay, where you can find these exceptions from your application logs itself. And again, if and you wanted to find why a specific method is consuming high memory irrespective to the allocated memory, and that's what you can find it from the ManageEngine APM inside, and we will discuss about that. And the buggy application code, if there is a slow DB call or a SQL query which is not properly structured, okay, might result in the slowness of your application performance. And how you can find which query is affecting your application performance, let's discuss that in the upcoming slides. Um, let's see a traditional way of application performance troubleshooting. So before we talk about this, I hope everyone is working from home from different remote locations. So you might be having a challenge for monitoring your applications from a different locations, or how well your application is performing, because the healthcare applications and financial applications SLA is quite important when compared to an other e-commerce based applications. So the stakeholders of these applications, the application owner of healthcare application and financial application, have a high responsibility for a quicker troubleshooting of an issue when it is raised. As and again, we are in the global pandemic situation, and the monitoring of your healthcare applications is again quite important. And how you can ensure, or how we can overcome the basic monitoring, and how we can switch back again using the modern way of approach, which in fact reduces the main time to time repair issue. Let's see that in the next slides. And when you receive a complaint, right, what somebody from the DevOps team do is they try to reproduce the issue. Say, for an example, an user is saying that the reports page in your web application is not loading. Then what they do is they try to get the logs, check if the specific any exception is happening with specific to that reports page or reports method, front end method, and they try to find it from the logs, which is a time consuming process. They have to identify the method, they have to go through the long set of logs, and again, they have to compare these logs with the product code to build a fix, right? All these time consuming process, and wherein we have to focus on the key business when the patients may not be able to access the application or the healthcare team may not be able to access the application while these troubleshooting is performed, right? So how to make sure that you deliver a good business experience for the key mission critical applications. Let's see that now. And let's see the modern approach on overcoming these problems, which I have explained. That is high response time, main time to time repair ratio, and delivering a best user experience as the key goals in your application performance monitoring. So ManageEngine Applications Manager provides you APM Insight solution, which is an agent-based solution of Applications Manager, wherein you get the primary metrics, performance metrics of your application. By understanding these four key metrics, one can ensure how well your application is performing in a global perspective, and you can understand the user happiness rating of your application when it is accessed. So AppDex, which is the application performance index score, overall average response time of your application. That is the primary score of how much time it actually takes to render the web page from your user's browser. That actually is the response time, which includes the first byte time and last byte time information. And again, coming back to the throughput, how much request that your application can process in a certain period of time. That is the volume for the upcoming request, which is a key metric in terms of application performance monitoring, and the exceptions happening in your application, how much exceptions is happening, whether it is important exception, that's what you can discuss it. So before we get started with this, let me switch back to the Applications Manager web console and show you how you can get started with initially. So we are in the Applications Manager web console now. I hope everyone can see the APM Insight page. In the today's session, we'll be focusing on Node.js and PHP. Whereas Application Manager APM Insight agent supports monitoring of Java, .NET, Node.js, Ruby on Rails, PHP. In the today's session, we'll focus on Node.js, and finally, we will discuss the key metrics for your Java-based applications as per the agenda. All right. So to get started, you can, once the Applications Manager is installed and it is up and running, you have this APM Insight tab available over here. Just choose the tab, and when you scroll down to this page, you will find an option called Download the Agent. And when this page is clicked, you will be redirected to our website, wherein you can download the agent depending on your application backend. Say if your application is programmed using .NET Core or .NET, so you can download the applications based on these. Applications Manager again supports your application developed using .NET Core platforms as well. So depending upon your infrastructure, you can download the agent and can get started initially. So once you know your application backend information, so let's assume that you have a Node.js application. Okay, and right here you will find the installation tips. After downloading, you can get started with the procedure mentioned here in this page. So let me show you a live demonstration of how you can configure your Node.js agent, monitoring of your Node.js application, and how you can view the performance of your Node.js application from ManageEngine Applications Manager centrally with all the full stack environment, which includes your database, traces, exceptions. Let's see that now. I'll switch back to the presentation again. So we are in the presentation now. Okay. I was explaining you the four metrics, that is the AppDex, response time, exceptions on these. And as a initial step to get started, the AppDex score, right? That's the way to get started initially, because that is a single point of SLA, service level agreement, for your applications. That is how well your application is performing. It is clearly pretty simple because the information we show is based on three counts: satisfied, tolerating, frustrated. The application stakeholder has to ensure that the satisfied user count is always high, which means that your application is performing well. And there is a backend calculation on how we calculate this AppDex score. If anyone of you is interested in viewing that calculation on how we find it, we will be happy to share it in the webinar chat panel. So let me know if you need this information so that our panelists will be sharing on how we calculate the AppDex score. All right. So let's get into the next topic for today. That is the identifying transactions and slow database calls that affect application performance. So we have discussed about the primary metrics, that is AppDex and SLA part, how to identify the business transactions which is affecting your application performance. So let me go back to the web console. So we were discussing about installing the Node.js agent, right? So let me show you how you can configure once the agent is downloaded and unzipped. Okay, so make sure that you move the agent to your application server running machine. That is, the agent should be moved to the Node.js machine configured. Okay, so once the agent is moved to that machine, open the configuration file of your application, either the startup file or configuration file. You will be finding the set of prerequisites, that is these lines, which needs to be added, including the following code in the first line of your Node.js application source code. Just copy this application, this set of code, and add it to your application. So in my case, I have already added, and which will be looking something like this. As you could see, this is my Node.js application code. I have added the required components, and I have specified an app name inside underscore Node.js. So from the applications manager web UI, you can find your application with this name. Not only that, you can specify the applications manager host. That is, if your app manager is installed in a different machine, you can specify that machine host name. Make sure that you are providing the SSL port number, because we use a secured encrypted communication between the agent and the app manager. So to ensure high level of security, to make sure that your security breaches doesn't happen, that's why we use a secured communication. We use an SSL port. So the default port, SSL port of applications manager is 8443. If any of you have changed it to 443 or any other ports, make sure that you are specifying that one. and not sure of your SSL port, you can go to the Applications Manager installation directory, wherein you will be finding a directory named conf, and you will find amserver.properties file, and you'll find the HTTPS port, and can use that values there. All right, so let me switch back to the web console again. So we are in the APM Insight page. Let's take the Node.js application, which I have already added to demonstrate. And I was explaining you from the presentation that the app takes an average response time. So here is the data from where you can view all these. This is a centralized single pane of dashboard for your application performance. That is, here you find app decks along with its count, response time of your application, throughput, request count, and the exceptions information. And the response time broken by its component. So when your application is accessed, definitely, as we all know that there's an HTTP call is involved, right? Because it's a web-based application. So considering that component, we give you the HTTP call values along with the app code and PG-SQL information. And request throughput, exceptions count, split up by the exception values, HTTP error rate, and error count details in a very high level details, along with the top 5 transactions based on the response time and top 5 slow traces, recent 5 traces from your based on the application accessed or the transaction accessed. You could find these information. All this is live. So the agent pushed the data from your application to the app manager every 1 minute, so that the data whichever is seeing is treated as the live data itself. Let me switch back to the presentation and discuss on how to find the transactions. So identifying the business transactions is again a key process to get started. So after configuring, you get all this data, right? But how do I know which specific part of functionality in my web application is not working? Or how do I find a specific transaction is affected? I can see all my web application is working fine. I couldn't find any issue. But one of my users says that he is not able to fetch the reports, and when he just choose the reports page, the UI is very slow. He is trying to fetch the record of your healthcare application, and he's trying to fetch the report of the affected patient's data. So it's a key process of your application, and fetching a report is important, right, for your application. So the data processing actually happens when someone fetches a report. Say if you talk the backend process, when they hit reports page, there is a SQL query is involved. So that's you have to find which specific transaction is affected, or which specific how to start with these options is again a question. All right. So find the slow business transactions based on the user's response time and the database calls. You can get the trace of the overall database operation and understand the time spent with a specific SQL calls. So that's an important metric. So let's see how you can troubleshoot your application performance using the APM Insight. So you have multiple tabs to find the business transaction which is affected, sort it based on its average response time. So here we provide you an option to sort, which shows you the data in an descending value. Okay, and also you can sort it based on ascending. So I have sorted it from the descending. So this specific transaction named admin action, when someone is trying to open this specific web page, I see that the response time is very high and the maximum response time is again impacted. So now I have found that this is the transaction which is having an issue. And again, show reports, as I was talking, show reports page is again a problem in my web application too. So when this specific transaction is clicked, you get to see the components of those, the various subcomponents, invocations, and response time broken by its components only for this specific transaction. That is the HTTP call, app code is how much, PGSQL is how much. You can find these values right here. And the request throughput split up by the exception dissimilar data, which I have shown, but this is specific for this transaction, that is the reports transaction on the events count. So not all the exceptions is important or needs attention. Only the critical or the fatal exceptions need an immediate attention from the operations team. So you can find how much types of these exceptions happening and when these exceptions are happening, find the historical data of the same and the error count. All right. So with this, let me switch back to the presentation and see the next topic for today. Analyze error traces to eliminate performance barriers. To explain this, I thought of giving you a use case for the application performance monitoring in an e-commerce industry. So I have one of my application built. It's an .NET application, and let's assume that I'm planning to launch a specific deal or specific lightning deal in a so and so time. I assume that my regular user count is 100 per day visitors of my website. So I have built my resources based on that. But in this specific case, I'm planning to launch a lightning deal which will happen for a full day. I need to make sure that how well my application can respond to this case, because the user count or the users hitting to my website will be high, and since they will be specifically looking into the lightning deals method, someone since multiple person access the same page, the web server take a long time again, right? And since all the user request is for accessing the same page, then there might be, and if the application is not programmed well, if there is a buggy application code, I might face an issue in the program code itself, right? So how you can ensure that you can overcome these situations proactively, or say you are planning to launch a new feature to your application, or you have enhanced a new set of feature, okay, and you wanted to find how well your application is performing, right? So these data is viewable from the app manager. That's by having a continuous set of monitoring. Let me switch back again to the web console. And right here, you can find the database, right? I was explaining that every application or transaction has the database activity involved, because without a database activity, the reports, let's take the same example. I'm trying to fetch reports how well my server response time is. So the data is stored in the database, wherein a specific select statement is executed in the backend to fetch the data from a specific table, and the data is populated to the users in the form of reports. So if you see, there is a backend queries involved. So how much time this query is responding, taking back to respond back to the users with the data they actually requested for. So again, we provide you a sorting mechanism to find the DB calls based on the response time. So I found that this specific insert statement in my web application is taking long time and the response time is quite high because it tries to insert a large amount of data. So when you click that specific query, you can find its average response time, throughput, request count, and errors percentage, including the other high level information as well. That is the operation throughput and operation response time again. And you can find the minimum response time and its errors percentage. So the 100 percentage of error seems to be there in this query. So I need to find why the errors is very high when the specific query is accessed, and you could see the operation by its caller. So when this page, my page dot do is accessed, so this query is involved, right? And the request count is 24. So this gives a clue of yes, some issues happening with this query. Now, how you can drill down and find the actual insight from the code. So before I explain it to you from the GUI of App Manager, I'll give you a same use case example from the presentation so that we can compare both and you can have a clear understanding of how you can troubleshoot it. So we are going to the presentation now, and yes, so I have shown you that a specific transaction, that is my reports page or reports page of my business transaction is having an issue. Next step, I found it. So what is next? Now I know that this is the problem. Where exactly the issue is happening, or why this specific method is causing the CPU spike. So get high level insight into the problematic code from your web application itself. This is the actual case where you can overcome the traditional way of troubleshooting, wherein you have to find this information from the logs, you can compare with the code, and then you find this information. So without going, you know, to the second and third step, you are directly coming to the fixing the issues part, wherein this time to time ratio is reduced, and you're delivering a rich set of user experience by setting up a proactive monitoring of how well your application is doing, because it acts as a continuous performance load tester. So let's see the screenshot. You can find it that there is a specific method is involved, and which is and it is calling a specific PGSQL query. And again, 15 method calls is involved in this specific transaction alone for the reports page, and which involves 201 SQL queries. Okay, and you could find the total time for each method along with its exclusive and total in milliseconds. So we traditionally, if you see this, if some issue is happening in your web application, right? So if it is running out of the memory, someone they actually recommend to increase the memory. They say you have to increase your system memory. You have to the free memory space is very less. They have to increase it. So this is what the primary solution that you get it from the typical old teams. But we wanted to find, okay, I know that the memory utilization is high, physical memory utilization is high, but which component is causing the memory utilization to be high, right? So you can find this information from the app manager from these data, getting the insight to the error traces. By this way, your application developers can perform rapid iterations just to ensure that you have stable application performance. So let me go back to the APM Insight, ManageEngine APM Insight, and see this information. We were discussing about the database tab, and let's get into the error traces. So these are all the traces for the slow transactions. Similarly, you can sort it based on its response time. So this transaction seems to be the problematic one. Let's figure it out why this is, and let's take that as an example. Okay, can see that this is the summary and the slow method call. So invoke.js is the method, and the count is 1 and the duration is 2 milliseconds. And in the front end, this is the statement get statement.js, and there is a PG call is involved. And when you choose the trace details, you can find the method invoke.js. When it is called, what is the SQL query which is getting executed. So this SQL query is taking executed, and there seems to be an process.js error. You can expand that and get the high level details of the same. So this is how your DevOps can troubleshoot it in terms of hybrid systems for your distributed web applications. And SQL statements, most importantly, remote external calls. So you can find the remote external calls and the exceptions, most importantly, and you could find there is an exception and an exceptions class. If the stack trace is available in the code, then you can find the stack trace right here. And the other metrics for the transaction is listed here, which includes your average response time of your application. You can see the recent and slowest values and filter those data. And if it is a thread-based application, I hope most of the applications will be multi-threaded applications. So that is the case. You can find the thread ID along with the instance name, response time of the specific transaction. So this is how one can find and troubleshoot the application performance. And there's a dedicated tab for the exceptions to get a high level view, which includes the top exceptions, and you could find the transaction and its count, and recent why exception traces, top error codes, and transaction split up by its exception values, transaction split up based on the error codes. So all these values, you could find it right here and along with its error count. Let me switch back to the UI or the presentation. Let's discuss about the benefits of modern versus the traditional approach, as it was saying. So there are key benefits. You can ensure that your application is available while you work from a different remote locations, and there is no need of physical checking of your data centers, whether it's a green data center or it's a hybrid data center. The agility of your web application is improved in a global scale, wherein you can focus on core operations part of your primary applications. Cost reduction is definitely reduced because the amount spent on new hardware is drastically reduced. Why it is reduced? Because you can directly pinpoint and see which specific component is causing the slowness to your applications. That is SQL code and through methods. And instead, you don't have to just increase your CPU or RAM, right? This definitely you are fixing the problem, which is causing the CPU or memory spike. That is eliminating the issue from the root, right? So this is a complete permanent solution that one can get from the APM Insight. Compliance tracking. So if you have applications used by your internal users or used by any students or used by any of your other high security purposes, in that case, you can find which specific transaction is widely used, and you can use this data for the compliance reporting also. The operation efficiency is again boosted because you are having a continuous monitoring and it's being proactive. The tool is capable of performing automation and orchestrations That's how one can improve the operational efficiency and manual work is drastically reduced. You get a whole new dimension of your application performance monitoring, which was never seen before. So we have discussed about finding the problems and fixing it. So now taking action to resolve the problem. As we all know, the developers uh, make rapid iterations. They develop a new code, they compare it, they troubleshoot it by modifying your SQL query. They try to adding a caching to enable faster performance. Either it could be a web caching or the code level caching. So once they have identified, they follow your regular SOP, that is the standard operating procedure, and they modify your query or fine tune your application code. So this is how your application is again fine tuned by using APM Insight. So this is the developer's turn that using the suggestions of APM Insight, they can perform these activities. Now let's see the business benefits. After implementing the APM Insight, the real world implementation seems to be you could find that there is a 70% of reduction in the time spent in the performance troubleshooting because we are overcoming the traditional way of manual process of checking the logs, raising an incident, again routing to the developers, reproducing the issue. We're not doing it anymore. We are rather focusing on the core operations part by keeping a track on the business metrics, and we are going from the top to bottom up approach. And 60% reduction in the functional testing of pre-production commits. Uh, Say, for example, if you're planning to deploy a new feature and for your production code, and you're not sure how well this feature is going to affect the other parts, or if there is going to be any breakage of this specific feature to the other functionality sets. So you probably some developers might have developed, built a fix for a security exception. However, that is impacting the other functionality set of the reporting aspects of your web application, which the developers were not sure because they have built a fix, they have built a new deployment, production deployment for the security fix. However, that created a breakage for the other functionality. So you could reduce these type of continuous issues by implementing the APM Insight. That is the 60% reduction in the pre-production commits. And as I said, it is quite agile. It is 90% suitable for agile and fast-moving environments for custom in-house developed applications. Now let's see the possibility of implementing the automation for your application performance troubleshooting. The ideal goal of implementing the automation is to reduce the time spent in the repairing. So how once the application issues identified, say for example, um, let's assume that the worker process is consuming high CPU utilization and you need a specific script to allocate some more application tools for it, right? In that case, you can create a scripting automation. App Manager is capable of executing the PowerShell scripts as well, and it is capable of executing a shell and batch script from a remote machines so that you can implement automation and orchestration. And for your Java-based applications, you have to keep a track on the heap dump memory, that is the heap dump non-heap memory. Along with it, if it is running out of the memory, you can trigger heap dump automatically. The tool is automatically capable of triggering a heap dump if memory utilization is going more than 70%. So you don't have to keep a track on the memory itself because once the once the set threshold value is violated, ManageEngine Applications Manager will automatically send you a thread dump or heap dump to the admin names. And going one step beyond, the tool is capable of sending these alerts in the help desk instant management tools. And the tool is capable of integrating with Service Desk and Service Now out of the box. And if you have any if you're using any other tools like BMC Remedy or any other tools like Big Panda, then you can very well integrate it using our webhook automation, which is available from the UI. So let me show you that option also so that you can have a clear understanding. So these are the various types of automation profiles that have, which includes the creating a ticket, Java heap dump or thread dump based action. And so say, for example, if you wanted to trigger a heap dump or thread dump, or a more proactive approach, that is performing a garbage collection for your Java applications. That is the tool itself capable of performing, and you can specify the number of GCs and delay between GC. You can specify the GRE for which the Java garbage collection needs to be done, and you can automate it. So let's get into the final topic for today, that is the additional insights for Java-based web applications. When we talk about Java-based web applications, the JVM acts as an abstract computing machine for your Java-based applications. You can monitor your Java components like not only the heap and non-heap memory. And apart from these specific components, threads plays a key important role because multi-threading is enabled if you have enabled it in the code. So you have to ensure that how much memory is consumed by your threads. If there is a memory leakage, how you can understand of because of which specific component the memory leak is happening. Okay, and you can find which method is exhausting your memory. And garbage collector, you can get complete high-level details of fine-grained collected objects count versus the split up information. So let me show you this, where you can find this information from the Applications Manager Web Console. So this is specifically for the Java-based web application if you have deployed any in-house developed Java applications, and if you wanted to monitor it using App Manager. So let me take you to the Java-based app. So the APM Insight tab, I have, this is our demonstration site, and you can find the JVM tab right here. So when you choose this JVM, you could find the high-level details of the Java-based web application, which includes the GC and threads information. So let's go back to the presentation and have a quick summary of what we have discussed in the today's session. We have discussed about configuring your application performance monitoring of your Node.js applications in a very basic scale. And if any one of you need high-level configuration assistance, after this webinar, a feedback form will be sent. When we exit this webinar, kindly make sure to fill the pop-up so that we will reach out to you for providing you an customized assistance. And we have also discussed about analyzing the slow methods and DB calls for your business transactions and getting the code level insight for the stack traces of your error transactions. Thank you for your time. Stay safe against COVID.